Hi, welcome. In this video, we're going to talk about memory management and dynamic memory in C++. So let's get started. All right, so memory management. So in C++, you can statically allocate memory or you can dynamically allocate memory. So static memory allocation is done like when you declare a variable. So if you say like int x, that is allocating memory, and you are saying that I need a piece of memory the size of an integer, and I'm going to call it x. Or if you need an array, you would say I need an array to be size 100, and that you know the size already, and so you're going to get allocated 100 memory cells, all the size of an integer, and when it compiles, it's going to give that, when it executes, it's going to give that to you right away. It allocates the memory. That's what we've been doing. We've been declaring variables and allocating memory, and then you learn about arrays, and this is how you would declare a static array. So it's going to be this size 100. If you don't know what size you're going to need, you can use pointers. So pointers, you use this asterisk here, and then you also use the keyword new. And this will dynamically allocate memory for you. So for example, if I wanted an integer, I could say int ptr. That's how you declare a pointer. And then when I'm ready, I can allocate it to be a particular size depending on what size it's going to be. And that you would use that in times when you don't know how much memory you're going to need. And it's a very big feature in C++. All right, so static memory is allocated at compile time, and dynamic memory is allocated while, that's why dynamic means during execution or while it's running. All right, so let's talk a little bit about how programs work. So you have a program. Your program is stored on a disk or somewhere on your computer. When it is a program, it just is basically just code. There might be data that's associated with it, but it doesn't actually, your computer doesn't really do anything with it until it becomes active. When it becomes active, it's called a process. So when you take a program that is just static and just sitting there and it's not doing anything, and you turn it into an active entity, your operating system needs to do a lot of things. It needs to bring it into memory, and it turns it from a program which is inactive into a process which is active. So you have a whole bunch of programs. You can think about it. You have a bunch of programs sitting there on your computer, but until you actually, type a command or click on it, it's just sitting there inactive, waiting to do something. Once it becomes active, the operating system gets involved and it loads whatever it needs. There's different memory management techniques, which are discussed in a different class, but it at least needs to bring into memory enough data to get the program started executing. All right, so the CPU can only access main memory or obviously the registers. And main memory can take many cycles, and it's managed by your operating system, and there's a lot that goes into it. However, you can manage memory in the sense that you can allocate additional memory or deallocate memory using the C++ programming language. So this is kind of an idea of how the address space, so the address space of a process is what is in memory, and your operating system presents to each process its own, well, there's a lot of different things, but in overall, it presents to each process its own view of memory. So this process thinks it has, say it has 16 kilobytes of memory. It doesn't, the size doesn't really matter, it's the concept. So say this is process one. Process one thinks it has this, but in reality, you have a memory map here, and process one could be broken up all into memory and managed by the operating system, but process one thinks it starts at 0, but it doesn't really. It just, this is a virtual representation of the process, and each process has its own, the operating system works very hard to present to each process its own virtual representation. So you have different sections of each active process. You have the code part, and you have the heap, and you have the stack. So the stack is for variables that are declared, and then the heap is for dynamic memory. So there's a free space, and again, this is not actually how it's stored in memory, but this is a representation that each process gets for how as a visual virtual representation. All right, so this is an abstraction of physical memory, and just to get an idea that each process has its own memory state of the running program. So keep in mind, a program is not a process and is not active and is not using system resources unless it turns into a process. And you have your code, your stack, and your heap, and there's other things, but that's the basic structure of what's used for each process. So here's an example of code. This is an example of a dynamic allocated array. So you should be familiar with arrays before we're talking about now dynamic arrays. So to declare an array, you would use the data type, say double, and scores, and say size 50. So this right here, this is a static array. And where would you declare this? You would declare this, anywhere in any of your functions, but in this case, if we wanted to, we would just declare it right here in our main function where you declare your variables. But this is what would be called a static array. You know how many scores you're going to have, and you would, along with your static array, you would put like a count, like an S count, or I can just put a count here. And at the beginning, let me put it over here. So I have at the beginning, and please review the array section, but at the beginning, our array has a count of 0. Our static array has a capacity of 50. You could put 50 scores in there, but until you've added any scores to the array, the count is 0. The count is very, very important because the count lets you know how many cells have been in there. So how many scores, how many doubles are in your array. So if your size is 50, when you're using a static array, you're not guaranteed that you're going to have 50. It's not going to be full of 50 scores, but you could reuse this static array for different purposes. So that's how a static array works. A dynamic array, the only thing that's different about a dynamic array is you don't put the size immediately. What you do is you put the size dynamically while you're executing, right? So we have this grades would be one array, and we have grades 2, which would be another array. And you can see here that they're declared with pointers. And so what would happen is instead of saying I want grades to be size 50 and grades 2 to be size 100, I can ask the user how many I want, and then I just use this type of instruction right here with the keyword new to allocate for my grades. Now you will see here that, okay. So you will see here that there's two different ways that we're filling the arrays here. So the first way right here is what you will be doing in your assignment. This is filling the array. You're getting the size, and you're going to allocate the memory before you pass it to the function. The second way is that you're going to fill the array in the function. So you're going to get the size through a function, and you will see here it has two symbols here because it's a pointer to a reference. All right, so we're going to focus now. We're just going to focus on this one, the first grades, and read the code. So we have our variable grades, and we have our variable size. So these are This is a static variable size that we're allocating, and this is a pointer to a double. We ask how many, so say the user says I want to put in 10. So then what we do is we use this keyword new to make an array of size 10. So now grades has become an array of size 10. Then the fill array function, we just pass our array to the function. Right here you can see you pass your array. You don't need to put any brackets because it knows that it wants a double array. And then we pass the size to the function. The size here in this case is going to be 10. So the 10 would come in here and a pointer to the array would come in here. And then we use this fill array to fill the 10 grades into the array. And then after we do that, we can take the same array, grades, and pass the pointer here, the same size, which is a 10, and then this is going to print the grades onto the screen. Please review arrays. Once you have your dynamic array, you just treat it just like any other array. So it's not like you have this dynamic array and then you have to do anything. What the dynamic lets you do, it just lets you allocate the memory dynamically during execution. Now in this the second case here, we have a pointer, grades 2, but we're going to fill it. We're going to get the size through this function. So we're going to allocate memory through a function. So that's why this has a double pointer to a reference. So that takes a pointer to a reference. And here, but you can see here, we're doing the same instruction we were doing before, only we're filling it with GR, because if you have in memory right here, so the way that this works, we have grades 2, which points right here. So it's going to be an array of doubles. When you pass it to this function, you have GR, which is going to point to the same place. So when you fill it, you're going to fill in the doubles right here. When GR points to it, grades 2 is also pointing to it. So there's two pointers that point to the same location. So this code right here, this is on Canvas. You can go through this and take a look at it and try things and modify it and make changes and practice. All right, so I'm just reviewing arrays here with you. So we have arrays. Arrays are usually, even though I draw a memory map like this, so say this would be an array of doubles. It would be X points here. This would be X at index 0, X at index 1, X at index 2, all the way up to X at index 7. So the values here. So this is the pointer. This is going to be the value that is here, 16.0, 12.0, all the way up to negative 54.5. This is a static array because it was declared to be of a size 8. And then usually you draw arrays in this fashion. It's easier to read them like that, but this represents a memory map over here. All right, pointers. So each memory cell stores data. Each memory cell has an address. So if you do like this, int X, then your operating system will find a place. It'll find a place to store X. We don't know what value is there because we didn't assign anything, but then X is going to have an address. Okay, the contents was whatever is here. So if I said X equals 10, then that's the contents that's stored there. So this is a memory map. There's another video of this, but I'm just going to go over it one more time. When you declare a pointer, you are not allocating memory. You are pointing to nothing. So it's very important to recognize that when you declare a pointer like this, you need to eventually point it to something. So when you declare variables like this, you are actually allocating memory. So you can point a pointer using address of, you can point a pointer using new. Now we've learned about new. So you can declare a pointer, and then if you use the keyword new, new is what's going to find you a place in memory to allocate. It could be just for one single, like you could have a class, a pointer to a class object, and then use new to allocate memory dynamically. You can have a pointer to an integer and use new to allocate memory dynamically, or you can have a pointer to a double and allocate an entire array, or you can do an array of objects. All right, so this is just reminding you how this works. These pointers right here now point to something because they were assigned to point to something. You could also say double PTR, and PTR equals new double and put size 20. And then, so when you first declare PTR here, PTR points nowhere. When you use the keyword new, then it's going to point here and you're going to get 20 doubles. So this would be PTR at index 0, PTR at index 1, etc. All right, another thing is there are two ways. Once you've done this assignment right here, there are two ways to access this. This would be num pointer. This access this location in memory. This is a location. So if memory starts at 0, this could be location whatever. It doesn't, it's not necessarily contiguous like this. All right, but there's two ways. You can go, this address could be num pointer, or this address could be the address of number. This address could be num pointer 2, or this address could be the address of number 2. And there's no relationship like this. I could say int pointer 1 equals address of number. And then I could have a different pointer 1, and pointer 1 would also point here. So just because this is num pointer and num pointer 2, there's not a relationship between the name of the pointer and the name of the variable. I just did it to make it more easier to understand. All right, so we also have value at. So you can take any variable and put an ampersand in front of it and get its address. That's address of. And you can take a pointer as long as it's pointing to something and put an asterisk in front of it and get to the value at. So if num pointer is pointing to this location in memory, in order to get to this value right here, you need to put an asterisk in front of it, and that gets you to the value at that. So basically it takes this pointer right here, which is a pointer to an integer, and by putting the asterisk in front of it, that takes the pointer and turns it into an integer. So this is an integer, and this is an integer pointer. So anything that's on this side is a pointer, and anything on this side is an actual variable. So this amount is a double, and value at amount pointer is a double. Amount pointer is a double pointer, and address of amount is a double pointer. All right, so here is an array. So when you declare this array, it allocates memory for you. It gives you 5 integers consecutively and the way in memory. So array nums is a pointer, and array nums at index 0 is an integer. Array nums at index 1 is an integer. And then you can assign values. So you can, once you have an array, this right here is an integer. Anything I can do with an integer, I can do with any of these it's the same as number, right? So I could say number equals 100, and that's going to change this 25 to a 100. I can say array nums at index 4 equals 20, and that's going to assign a 20 right here. So this is just assigning values to all the different. So this one is taking whatever is at array nums, which is 105, and adding 3 to it, and then taking that result and assigning it back to array nums at index 3. And there's no, the way that C++ calculates is it starts here and it counts a size of integer, size of integer, size of integer, size of integer. So there's no control for it to go out of bounds. So you have to keep track of how many cells are actually filled into your arrays. So here I took this num pointer and it originally was pointing here, and now I made a new assignment where I moved it to right here, because right here is the address of array nums2. And then I went, because I moved num pointer here, which is a pointer, I could turn it into an integer by putting the asterisk in front of it. So I got to the value at num pointer, and then that means I changed its value, and it also changed the value in the array because I went to the location in memory and changed the value. Why do you use dynamic memory? Because it allows you to have variable sized allocations. You don't have to assign, especially if you have large amounts of data, you don't want to be wasting memory by having, an array size 100 when you might only need 15 objects. Like say you have an array of class objects. It's useful when we do linked lists and trees and dynamic arrays. We are not doing linked lists and trees in this class, but you will see them in future classes. And you have more efficient utilization for larger programs. Like I just said, if we're doing small examples because we're practicing, but when you have large amounts of data, you don't want to use large static arrays and waste a lot of memory. Be sure that you use new and delete. So here's again an example of how to use new to allocate an integer. So this is just one single integer, so you have an integer pointer, you're just going to have one single integer whose value is 10. So notice that we're putting parentheses, not square brackets. And to free it up, you use the keyword delete, which was in that code that the code examples that are in Canvas all have delete. All right, so if you have an array, you use the delete with the square brackets. So if you want to allocate an array, this right here is not putting values in it. This is doing the size, right? So we have an integer pointer. We use the keyword new. We want to get 5 integers, and the name of our array is going to be ARR. So what we're going to get with this is, so when you start out, you have your array pointer. So if we had done this on 2 lines, or we had waited to get the size from the, so say you were waiting, you said int ARR, then you have a pointer that points to nothing. Then you ask and get the size. So say we have int size. Then you ask and get the size. Then we could say ARR equals new int, and it's going to be that size. So for example, if the user gave us the size 4, just going to use a different size than 5, what would happen then? We would get 1, 2, 3, 4 integers, and ARR pointer would no longer point nowhere, it would point right here. So the ARR is still a pointer, it points here. This would be ARR at index 0, ARR at index 1, ARR at index 2, and ARR at index 3. If it was 5, we'd get 5, whatever. All right, so you want to, once you do that, you can, well, let's make it size 5. So we can be consistent. So we have one more down here. We have ARR at index 4. So now I've made it size 5, so I'm consistent with this. So now we have a loop that goes from I equals 0, I less than 5. So that's 0, 1, 2, 3, 4. And we're going to assign values. So so we're going to start when I is 0, right? So when I is 0, so 0 times 2 equals 0. So right here is going to be the value 0. Then we're going to change I to 1. So here, that changes I to 1. We check, is 1 less than 5? Yes, it is. So now we have 1 times 2 equals 2. So the value 2 is going to go here at index 1. So this is the index, so this would be 1 and this would be 1. So the first time, actually I'll do it from the beginning again. We start, I is 0. So this is 0 and this is 0. So array at index 0 is going to be 0 times 2, which is 0. Then we go here and we change it to a 1. So now I is 1. 1 times 2 is 2, and that gets assigned here, so that's a 2. Then we go here and we change this to a 2. I is now 2. So this is 2 times 2 is 4. So array at index 2 is going to have the value 4. Now we're going to change I to 3. Is 3 less than 5? Yes, 3 is less than 5. So 3 times 2 is 6. So array at index 3 is a 6. Now we're going to change it to a 4. Is 4 less than 5? Yes, it is. So 4 times 2 is 8. So now this one is going to be 8. And now we're going to change I to 5. And now this loop is going to stop. So there's a couple of things to notice here, because I'm just going to erase this really quick. You can see here that this loop, these instructions are happening. They are happening. You do not need to have curly braces because it doesn't really need to go to the next line, but it should. To be better code, you should put this at the next line, but because it's a slide and there's not a lot of space, it's all on the same line. So this is going to execute as long as this condition right here is true. But now I is 5, so we test. Is 5 less than 5? This becomes false, so this is done. So now we're going to move on to the next instructions, which if there were more instructions, we would move on to the next instructions. And I do believe that I'm not really sure what's here. Oh, this is just showing you how to delete an array. So when you're done using your dynamically allocated memory, you should always delete it. All right, so some things you should not forget to use delete. Remember to use delete. There is also an issue of dangling pointers, like if you delete something, so if you had in memory here, like this, and you have this pointers pointing here, and maybe another pointer too is pointing here, and then you delete, but you don't delete everything, you don't manage it right, and you end up with a pointer that points to nothing. So that's something you got to be careful about. Dangling pointers. I have an example of dangling pointers in the sample code. Deleting the same pointer twice could happen. And then here is just an example of how to use new for a class object. This is not an object list. This is just one single object. we have our class car. Obviously, we should have more things that are in our car, but this is just a review. This is the constructor. So you should be familiar with a constructor. This is called a destructor. Anytime you're going to be using dynamically allocated memory, you should implement in your class a destructor. So if you're going to dynamically allocate objects or dynamically allocate arrays of objects or anything, any kind of dynamic memory allocation, you should always include a destructor in your class. So in future assignments with classes, we will be, now that we've learned about dynamic memory allocation, we will be adding destructors to our classes. It's not a very big deal. It's just it just should be added. All right, and this is how you create a new car. So you would do a pointer to a car, and then I would like to have a new car. So the name of the object is my car. And when I'm done with my car, I delete my car. All right, so thank you very much. This is an overview of dynamic memory and memory allocation. Have a great day.